Hello all, welcome to the design pattern series. In this series we are going to cover different design patterns that are available in C Sharp. In this series we will cover the basics, its uses, and at the last we will look into example for the respective design patterns. And in today's course we are going to look into adapter design pattern. Now moving to the topics which we will be covering for this particular design pattern. So while learning this design pattern we will be covering below topics, that is what problem the adapter design pattern solves, then what software design principle it follows, and how this pattern can be applied in your code, and which design patterns look similar to this adapter design pattern in theory, because there are a couple of patterns which might seem similar to adapter design patterns but they have different purposes. So we will go through those. The adapter design pattern is one of the most popular and useful design pattern, and it is pretty common in C# code. This type of design pattern comes under structural pattern. It's very often used in system based on some legacy code, where it makes it possible and easy for modern classes to work with legacy code. It's also used commonly for adapting the result types. We will see the examples for both and we will go through the details for same. Our real life examples could be a card reader, which acts as an adapter between memory card and laptop. So first you need to insert the card into card reader and then the card reader into the laptop. In this case, the card reader is in the role of adapter, which makes it possible for two different interfaces, that is memory card and the laptop, to communicate with each other. In this entire course, at number of places I will be mentioning client code or a client application. So what I mean by that is class. A class will be a client class if it's calling any method. So in case if we are creating an adapter class, so whoever will be calling that adapter class will be a client for it. So do consider that. Now let's go to the definition. If we go by the definition given by Gangs of Four, the adapter design pattern converts the interface of a class into another interface that client expects. Adapter lets classes work together that couldn't otherwise because of incompatible interfaces. This definition might not give a proper understanding about adapter design pattern at first, but we will go through different examples. We will look into the implementation details for adapter design pattern to get better understanding about it. This design pattern is often used for working with other classes without modifying the source code. For example, if you are using a third-party class whose response cannot be consumed by the client class directly, and also we cannot modify the third-party class because that code won't be accessible to us. So in this situation, you can introduce an adapter which will convert the response coming from third-party class to the response which client is expecting. Here we are not changing the behavior, we are just making the communication possible. If I have to give one more example, then the example would be, say you have some legacy code in your application, and say you have now introduced a new class in your application which needs to communicate with legacy code. So it will be calling some method from legacy code, and the response coming from the legacy code is not something which client is expecting. So say the client is expecting JSON object and the legacy code is returning the XML. So in that case, the client code cannot directly go and proceed further with the response it receives. So first it will need to convert that XML response to JSON object, then only it can proceed with the further operation. So if we do this, then we are violating single responsibility principle, because we are adding one more responsibility, that is converting XML to JSON object in our client code. So we need to avoid this. And one more thing will be, in case if you are directly using legacy code, if you want to directly call the legacy code from your client application, so in that case you will need to create an instance of legacy code and then call the method. And do remember, new is glue. So to make communication possible, what you can do is you can add a layer of abstraction, like using interface, and you can create adapter class which will have all the logic for communicating with the legacy code and then converting the response received from legacy code to the desired response, like the client, whatever the client is expecting, so converting it to that and then responding it back to the client application. So this way we are not creating a new object of legacy code into your application directly, into your client code directly. We can use dependency inversion principle as well to make this communication, make this object creation easier. Introducing adapter design pattern will help us to manage this particular situation in a better way. And so in simple words, adapter works as a wrapper around adaptee to make the communication possible. So adaptee in this example will be a legacy code. So it will create a wrapper around it and will make it possible for a client to communicate with the adapted in easier way. Now let's look at the representation of adapter design pattern. So in this diagram, actually, you can see This is the client. Client means any class who will be calling the adaptee. Adaptee in our example was legacy code. So say this adaptee is a legacy code which we want to call, and client is supposed to call some method, some function. This in this example, it's a specific request, but the response given by adaptee is different than what client is expecting. So what we can do, we can introduce a layer of abstraction using an interface. So in this diagram, the target is an interface. So it will have one method declaration. Then we can create a class, adapter class, which will which will implement the target interface. And what it will do, it will also implement something from adaptee class. And then in the request method, it will call the specific request method from adaptee. So that way it will call the legacy code. Whatever the response it receives, it will convert the response into whatever the response client application is expecting, and then it will return back to the client application. From the diagram, the idea might not be clear to you, but when we will be implementing it, so that time you will have better understanding about it. Let's go to the Visual Studio and see the actual implementation for adapter design pattern. Okay, so to show you how this adapter design pattern works, I have created one sample solution. This is a profile management system. So what it does, we keep user profiles in one JSON file, and then using this profile manager class is there. What this class will do is it has one method, get user profile. So once we call this method, it will go to the JSON file, it will read all the profiles available in that JSON file, and then it will return those whatever the list of profiles it receives, it will return. And this from this program.cs file, we are calling that get user profiles method, and then we are printing that details, all the details related to those profiles on our console. So let me just show you how the output will be. Yeah, so you can see currently I have three profiles in JSON file, and once we call this particular method from profile manager class, so it returns us back those three profiles, and then we are printing these profiles on console. So now let's go to the profile manager class. If you can see the code, currently we are reading a JSON file, and this from this JSON file only we are returning the response. But in future, we might be asked to read these profiles from database. So there will be one more option available. So we are not supposed to just read data from JSON, but based on the request, we might need to read data from database. So in that case, we will need to add one more condition here, or more code to read data from database. So let me just show you how, in that case, how the code will look like. Okay, so I have quickly done those changes. So for to implement this easily, or the in the quickest way, what we can do is now the get user profile will method now will receive the source from where it needs to read all this data. So there are two sources currently, a JSON file and a database. So in case if the request comes for JSON file, then it will go and execute this code. And in case if the source is database, then it will go and read the data from database. But for this example, actually what I have done, I have not done any actual database implementation. I have just created one list, and from that list only I am reading the data. I know this is not the best implementation because it's violating the solid principles as well. And there are too many responsibilities in this class. And then we have introduced this else if logic. So let me do one thing. I will create two different classes, one for handling the JSON request and the other one for handling the database request. Okay, I have done the changes, and now this class, profile manager class, looks better and cleaner. So what I have done, I have created two different classes. One is for entertaining the JSON request and the other one for entertaining the database request. If I go to JSON request repository, what it does, it has one method called get profiles, which accepts file path as a parameter. Then based on that path, it will go and read the data from the JSON file, will convert into the desired response, and it will return it back. And same for database request repository. It The difference between these two classes is the database repository do not require this file path, so it can just if we call this get profiles method from this database repository, it will directly go to the database, will read the files, and will return the records in the response. So from this implementation, if you consider this implementation, it is still not good because we don't have any interface, common interface for communicating with these two repositories. And even if we go with creating the interface, common interface, so we might face some challenges. There might be some existing interfaces as well for this communication, because currently we have not created any, but there might be a scenario where for one repository we already have an interface, and the other repository is just newly introduced. So but in this case we have two repositories, that is database request repository and the second one is JSON request repository. If you look at the implementation, the JSON request, this particular repository method, get profiles method, needs file path as a parameter. Whereas in database case, we do not need that parameter. So in case if we want to create an interface out of this, so we need to create an interface which will be common to both, because we cannot define a method which will accept a file path. So that file path is not required in database request repository. So that way that interface won't work properly, because that you variable or parameter won't be useful in database request repository. So to come over this, what we can do is we can create an interface with a method called get profiles, and then we can create an adapter for communicating with this database request repository and JSON request repository, where we this common interface method will be implemented by both the adapters, and that way we can make this communication possible. So I will just show you how to do that. I will do the code implementation and will show it to you. Okay, I have done the code changes, required code changes. So what I have done is now I have created one interface, and this interface has only one method called as get profiles, and it will not accept any parameter. So this method we can commonly use for both JSON repository as well as database repository. And then for implementing this interface, so this interface actually will be implemented by adapter class. So adapter class will now have implementation for get profiles method. So for adapter class, actually I have not created any separate CS file. So for database request repository, what I have done in the same CS file, I have created this class, new class, and it's implementing iRepository adapter. And in the implementation of get profiles, what we are doing, we are creating a new instance of database request repository, and then we are calling the get profiles method. So this implementation is simple for this database repository adapter. But when it comes to JSON request repository, I have done the same thing. In the same CS file, I have created a new class. We are calling it as adapter. It's implementing from iRepository adapter. For JSON repository, we need file path. So what we have done, while in the constructor itself, we are accepting this file path. And in grid profiles implementation, what we have done is we create an instance of JSON request repository class. Then to the git profiles method, we pass this file path. So this way we have created an interface which is common for both the classes, both the repositories. And now this is a common interface we can use in program file profile manager. In profile manager, what we have done is now we have created a variable for holding the object of a JSON repository adapter and database repository adapter. So based on the request, so in case if the source is a JSON file, then the object for JSON repository adapter will be created, and in case if the source is database, then database repository adapter will be created. And when we create object of JSON repository adapter, we are passing the source, or I will say the path of the JSON file, which will be used for reading the records. I know this is not the best way for handling this situation as well, into the entire situation, because we are creating the instances in profile manager, and in case if new source comes, so that time also we will need to add one more else if statement to handle that request. But this can be handled in a better way. We will look into that later. But uh, the motto behind for creating this JSON repository adapter and database repository adapter is like, in case if the new source comes, so what we will need to do, we will need to create a new class. Say the request now comes for API as well. So we will create one repository for handling the API request, and that API can implement that particular repository, new repository can implement iRepository adapter, and through that, so by end of the day, we will have only one interface, a common interface. Through that, we can communicate with the different sources. By creating two different classes for handling the JSON request and the database request, we are making sure, say in case if in future third source comes, say it's a API or WCF service, so we won't need to make any changes in profile manager and go and create write the entire logic in profile manager. So the best way for us will be create a new class, write the logic there, and then call that class from profile manager. Now let's do one thing. Let's make some changes to handle this object creation in a better way. I will do those changes and will show it to you. So what I have done is now I have created constructor for profile manager, which will receive the instance of whatever the adapter we want to use. So now if we call this particular class from program, so that time actually we will need to pass the instance as well. So this will remove the need of creating interface here. So this thing now we will need to do in program. And in case if we have dependency injection already implemented, so this thing can be handled in a better way. Currently we don't have, that's why we need to pass these instances from program.cs file. So I will now move this code to program.cs file just to see how it works. And now in program file manager, what we can do, we can remove this code. It is not required anymore. This as well. So we don't even need to need these sources as well. Yes, so I will remove this entire code. So we only need this one line. Let me format it. Yes. Yeah, so we have very less number of code now, and we don't even need this source. So what our profile manager is doing now, we are just calling this get profiles method, and the get profile method will invoke the instance whatever we are receiving in a constructor. So whatever adapter we are receiving, so the method from respective adapter will be called. And in program.cs file we don't even need to pass this. And now if I run the code, yeah, so as you can see we are receiving the response as expected. So in case if I want to get response from database repository, all I need to do is pass database repository. Yes, so the instance of new database repository adapter. Yeah, this can be handled in better way if we have already implementation for dependencies in our project. But as of now we are not using that completely, so this way we will need to do it. Yes, so both approaches are working fine. Now with these changes what we are able to achieve is, in case if in future new source comes, say API, so that time we will just need to create a new separate CS file. We will need to handle all the logic there, and using the adapter we can make it compatible to work with this. So that time we will just pass the object of the new adapter and things will work fine. We won't need to make any changes in profile manager or anything. Only while calling we will need to pass the respective repository object. And this way actually adapter is helping us to solve the problem, because this was not possible with the previous approach. In the previous approach we had two different classes, and the two different classes were behaving in two different ways. So it was not possible for us to pass that instance to profile manager and then invoke the respective methods. We have also followed the solid principles as well. This class now only has one responsibility. We are not bombarding it with multiple responsibilities. So we are following the solid principles. Adapter pattern design pattern is helping us to follow the solid principle. We have extracted one interface as well as we have no separate classes for handling the responsibilities related to JSON request as well as database request, and there will be new classes for handling the future responsibility. There is one more way through which adapter design pattern actually helps us, and one more way to implement it. Like let me just show it to you. In database request repository, we are actually dealing, or I will just go to JSON request repository, better way. We are reading records from JSON file, and most of the time when we read data from database or any different source, so it might have detailed information. Let me just show you sample data in the JSON file. So this particular file actually contains details for modified by, modified date, role, created by, created date, is active, whether it is active or not, and these things are not required by the client application. So all this information is not required by client application. So they might be just requesting for name and address. So in that case, when we are reading all this information from the JSON file and then passing it to the client, so that time actually we are just passing the selected fields. So to handle such situations, we can use adapter design patterns where we can write an adapter which will adapt for response type. Let me just show it to you. I have already created one adapter for same. It is called as a profile adapter, and if you look at it, what it does is it receives the list of profile data. So this we can do in a database request repository as well as in JSON request repository, but that way we will be duplicating the code. So to avoid that, what I have done, I have created an adapter where it will be receiving a list of profile details, and then it will create that list into profile response list, and it will returning back. So we might also handle different situations. Say in case if the user profile is active, we need to perform some business logic, or we need to just perform check whether that profile is active or not, then only add to the list, or based on different flags we might need to skip that record or perform certain operation, or uh, pass or check some value from the enum or anything. So there can be different kind of scenarios. All those scenarios can be handled in this adapter class. So this is one of the example for adapter design pattern, where we are based on the response type, we are adapting the responses. Now let's talk about similar patterns. So this adapter design pattern might look similar to you in when we compare it to decorator, proxy, or bridge design patterns, because of the theory part. But the decorator design pattern has a similar structure, but the intent of decorator is to add functionality. Then when we talk about a bridge design pattern, it is very similar in structure, but it intent specifically is to allow interfaces and their implementation to vary independently from one another. And if you talk about a proxy design pattern, so the structure might look similar, but its intent is to control the access to the resources. So all these design patterns are not same when it comes to implementation, but they might look similar, but they have different purposes. I hope this course gave you better understanding about adapter design pattern, and you will feel more comfortable to use it in your code. Please do subscribe to my channel and hit the like button. And in case if you have any questions or queries, do let me know in comment section.